Hello, welcome back to another video. I hope you're doing well. In this video, we're going to look at finding the inverse of a matrix. It's another 3 by 3 matrix, so this is the same sort of thing as we did in the last video. The only catch is you'll kind of see that we run into a problem at a certain point as we're trying to find the inverse of this matrix that I have, okay? And so if you remember from our last video, to find the inverse of a matrix, you put the identity matrix on one side of the matrix that you have, okay? So you take your original matrix and put it in, and then you put the identity matrix of the same size in there, okay? And the identity matrix has ones on the diagonal and zeros everywhere else, okay? So you put in your identity matrix, and a lot of the time, I think in the book, they usually put some dashed lines here just so that you can kind of keep track of the two pieces of this matrix, okay? And so then our strategy is we want to try and do row operations so that I get the identity matrix over on this side, okay? So we're going to do row operations to the whole matrix and get the identity matrix on this part of it. Then whatever is left over here is the inverse, okay? So first of all, when doing our row operations, we want this place right here, we want that to have a 1, right? And so to make that be a 1, there's several things I could do. I could divide by 2 across the whole row to get rid of this 2, okay, so that I'd have a 1. But if I were to do that, if I divide all of this by 2, I get fractions on these others. And I don't particularly like fractions. So I'm going to, instead, if you notice, there's ones right below this 2. So I'm going to switch rows. I'm going to switch maybe these 2 rows, the first and the second row, okay? Row 1, we're going to switch you with row 2, okay? So what happens when we do that? We get, well, row 2 just becomes row 1 now. I'll put in my dots, 0, 1, 0. So this whole row moves up, right? And then the second row becomes the first row from before. Okay, there we go. And then the last row we didn't do anything to, so it just stays the same. Okay, so that's our matrix after we switch those 2 rows. Okay, so I now have a 1 up there in the corner, and I need to get zeros below it, right? So I'm going to use row operations to cancel out those 2 numbers. So from a positive 1 to get to 2, I'm going to do -2 times the first row and add it to the second row. That should cancel out this 2 here. And then 1 and 1, those are already the same, so I just need to put in a negative on the row 1 and add it to row 3. Okay, that will get rid of those 2 places so that I've got zeros there. Okay, so write this out. We've got 1, 2, 7, the first row doesn't change because we didn't do anything with it. Our second row, we're taking -2 times the first row and adding it down to the second row. So -2 times 1 is -2, plus 2 is 0, just like what we wanted. -2 times 2 is -4, plus -3 is -7. Okay. -2 times 7 is -14. Minus 7 is -21. Okay. And then we do the same thing over here too. So -2 times 0 is 0, plus 1 is 1. -2 times 1 is -2, plus 0 is -2. And then -2 times 0 plus 0 is still 0. Okay. Cool. So that's our second row. Now to get the third row, we were doing negative times the first row and adding it down, right? So -1 times 1 is -1, plus 1 is 0, just like what we wanted. -1 times 2 is -2, plus 1 is -1. Okay. Then -7 plus 4 is -3. Okay. And then -0 plus 0 is still 0 here. -1 plus 0 is -1. -0 plus 1 is 1. Okay, so we're just taking our rows and combining them together so that we get zeros there. Okay, so now that we have the first column is taken care of, it looks like the identity matrix. What do? Well, we want there to be a 1 right here on the matrix, right? There, we want a 1 along the diagonal, and then we're going to want a 0 below. Okay? So, I mean, there's several ways that you can get a 1 there, but where this one is already a -1, maybe what I'll do is I'll switch those two rows and then times by a negative so that I get +1. So I'm going to do my second and third row, I'm going to switch them. And then we'll go from there. Okay, so I'm going to switch those because 1 is a little bit closer to, or sorry, -1's a little bit closer to 1 than 7 is. So I'll do that. So we're going to switch that up. This becomes -1, -3, 0, -1, 1. Just switched our rows. Then we've got -7, -21, 1, -2, 0. Okay. Then we've got still up here the same stuff. Okay. So we've got our matrix now with a -1 here. So what I'm going to do as well is to get rid of that negative there, I'm going to do, here, maybe I'll write this, well, I'll just do it here. Negative times row 2, we're going to do that first so that I get a +1 there. So I times by a negative, so I'm just going to switch all these signs here so that I get a +1. Okay. So I just times the whole row by a negative so that I have a positive 1 there where I wanted there to be a positive 1. Okay? Equivalently, you could have divided this by -7, this row. You could have left it there and then divided it all by -7 to get a 1. And that would be fine as well. I just don't like dealing with fractions. So, okay. So there we go. So now I just want to get rid of the thing below the 1. So I want to do what times 1 will give me 7? Well, I'm going to do 7 times the second row and add to the third row. So 7 times the second row and plus the third row. Okay, what do we get when we do that? We get, well, the top row stays the same. Okay. And then our middle row stays the same. It's just our last row that's changing. Okay. So when I do this, when I do 7 times the second row plus the third row, so I do 0 times 7 is 0, plus 0 is 0. 1 times 7 is 7, plus -7 is 0. Okay. 7 times 3 is 21, plus -21 is 0. Okay. And then 0 times 7 here is 0, plus 1 is 1. 7 times 1 is 7, plus -2 is 5. 7 times -1 is -7, plus 0 is -7. Okay? Okay, so we're getting close. In fact, we're actually basically done with this problem, but I'll show you why. So if I were to continue this process, right, I have 1s here and here now, and I have 0s below them, okay? For this to become the identity matrix here, I would need to get a 1 right here. I really like that red. It's really bright. Okay. We need a 1 right at that position for it to work. Okay. Well, the problem is that's a 0 there, right? And I can't get there to be a 1 there. I could if I messed up the rest of my matrix, but I can't just times this row by a constant and get a 1. If there was some non-zero there, let's say instead of being 0, there was a 2 there. If there was a 2 there, I would just divide that whole row by 2 to get 1 where I want it to be. Okay? But there isn't, there's a 0, and no matter what you times 0 by, it's still going to be 0. Okay? And so there's nothing you can do with that. There's no way that you can get there to be a 1 there. And so if you do ever run into a row of zeros when you're finding the inverse, like a row of zeros in the thing that you're trying to make the identity matrix, it won't be possible. And so this matrix doesn't have an inverse. Okay, so there's no inverse of this matrix. Okay, meaning there is no other matrix that you can times this by and get the identity matrix. Okay? So hopefully that kind of helps give you an idea, again, a little bit more practice with finding inverses and how to tell if there isn't an inverse. Okay? Thanks, guys. I will see you in the next video.